Hi, my name is Natasha, and I'll be presenting my project on drug consumption and personality. Following this agenda. What motivated me to do this project is the fact that drugs take a lot of lives, so I wanted to understand how personality determines the risk of drug usage. With those insights, better preventative measures can be taken. My two main research questions to achieve this goal were: can we predict drug consumption based on personality? And second, which dimensions of personality or combinations of them have more influence in determining drug consumption? To answer these questions, I employed supervised machine learning methods for binary classification between drug users and non-drug users. Most importantly, I needed to identify drug users. So let's dive in. The original dataset was collected by Elaine Furman through an online anonymous survey. I was able to obtain it through Kaggle, and it originally looked like this. As you can observe, participants reported the drug usage using this criteria, but I merged all of the usage reports into one class. There was a fictitious drug included in the survey, and those who reported its usage were removed from the sample for overclaimers. Then I decided to narrow the project to only three major illicit drugs: crack, heroin, and meth. Next, I created a new column named has used, which took a value of 1 for those who had reported consuming at least one of these drugs and 0 otherwise. Regarding the demographic of our samples, I'll show some distributions. This one's for age, gender, education, countries, and ethnicity. Then I dropped the demographic data since my focus was solely on personality, and finally, this was a clean data frame with each sample containing 7 numerical features aimed at predicting the target value. Now we can move to the model exploration part. For the first 3 models, I splitted the data into 70% for training and validation and 30% for testing. So the first model I tried was a decision tree classifier. I performed a grid search which does cross-validation with 5 folds and finds the best hyperparameters. The maximum depth hyperparameter is important because it affects the model complexity by limiting the maximum distance between the root and the leaves. The largest the depth, the largest the complexity, and so the risk of overfitting. For this specific task, 19 seemed reasonable since the topic is inherently complex. However, the performance was not good. Although we see good precision, recall, and F1 scores for non-users, it's not the same for users. Regarding this type of model strengths, they are easy to allow graphic observation of the interactions among different features. However, a weakness of this specific model is that it is too complex to even visualize it entirely. Next, I employed a random forest classifier using a similar logic for hyperparameter tuning, yet the score for recall of drug users was even lower. Some strengths of using random forest classifiers is that they try many decision trees classifiers and look for the best in just a few seconds, simplifying human work. However, a weakness is that they boost overfitting. Now we pass to the third model, which was a logistic regression model. Following the same logic, I obtained these hyperparameters. From this, the C hyperparameter is important because it defines how strong the regularization is. Regularization is the process in which we can balance how well the model fits the data and how complex it is, preventing overfitting and improving the generalization ability. With this one, I was able to obtain a higher recall for drug users than with previous models. For feature importance, the model uses an L2 penalty, and we can observe similar weights across all features, suggesting equal importance of all personality dimensions. A strength of using this model is that by incorporating regularization, we can prevent overfitting and improve model robustness, allowing to obtain the best recall among all models. However, this was still an insufficient recall. For the final model, which was a deep learning model, I did a new split of the data from scratch. This time, 64% of the data was used for training, 16% for validation, and 20% for testing. For deep learning models, we have 2 important aspects: the layers and neurons in each layer. The more layers and neurons, the more complex the model becomes, similarly as brain works. I first started with 2 hidden layers, and 60 neurons, but since I observed overfitting, I decided to reduce the number of neurons to 30. Even so, overfitting remained. As we can observe in the left graph, the model learns in the first epochs, but it is unable to generalize its training to the new data, its learning to the new data. This can be also seen in the right graph, where the recall improves linearly for the training data, but not for the validation data. Ultimately, we got a low recall for drug users again. A strength of deep learning models is that they are capable of capturing nuances better and find patterns that traditional machine learning models cannot. Thus, they are useful for complex phenomena. However, for these models to work appropriately, much more data is required. Since my dataset was not so large, this is probably why it failed. When comparing all four models, we can observe that the less flawed is the logistic regression model. Therefore, we'll take a closer look at its errors. By visualizing this confusion matrix, we can see that the model has a high recall of non-users. Even so, as I mentioned earlier, the important question here is not who's not at risk, but who is at risk. And for recalling who is at risk, the model only identifies 44% of them, so it is not useful for achieving the project's goal. Finally, going back to my first research question, I conclude that personality by itself may not be enough to predict drug consumption. As for the second question, no dimension of personality or combinations of them were found to have an important influence on drug usage. Other factors, such as demographic and life conditions, should be taken into consideration. So for future directions, I suggest this project can be reframed by incorporating the demographic variables to the models and increasing the sample size. Additionally, using ensemble methods could enhance the model performance. Here are some of the references I used, and that will be all for today. Thank you.